So in my last video, I introduced you to this component in this basic circuit. What this is an SCR Silicon Controlled Rectifier. Here's the actual part, MCR 100-6G, this particular Silicon Controlled Rectifier. It's in the TO92 package, like the transistors. All the resistors I'm going to use in this video are 2 kilo ohm resistors, by the way. You can use 470 ohms and above, because we'll be dealing with 9 volts. So anything above 470 or 470 will be fine. But in any case, as I demonstrated in the last video, the silicone controlled rectifier, the SCR, is normally off. That's why the LED is off and the resistor is off. It's not conducting. But if I take a resistor here and connect the middle pin, the gate, to the positive power supply, now you see that the LED turned on and it stays on. So I have over here basically the same circuit, except for instead of removing a component to turn this one off, I have to actually break open the circuit somehow by removing the resistor in this case. With this circuit, I have switches to do the work for me. So the gate, the middle pin of this SCR, has the wire here to this switch, which comes to positive. So when I close the switch, the SCR turns on. Now, I made basically a NOT gate here, and so when I push this switch, it'll divert the current that's coming from the resistor and the LED to this pin, away from this pin. It's also connected to the anode and to ground here. And so now you see it turns off. While I'm holding the switch though, of course, the LED will be on because it has a current path from resistor to transistor through the switch to ground. But it's not making it to the silicone controlled rectifier anymore. So it's actually off even when the LED is on. So now I move the jumper in front of the transistor, make it a little easier to see. This jumper's right in the middle there, the gate, the middle pin. And so when I hit this switch, the gate gets a positive charge here with the resistor limiting the current, and the SCR turns on. And when I hit this switch and get a good connection, it turns off. For some reason this switch is getting worn out or something. Doesn't connect as good as it used to. But in any case, what we have here is a basic flip-flop circuit in a way. And flip-flop circuit is a bistable circuit where, depending on what you just did, if you hit that switch, then it is on. If you hit that switch, it's off. So there's 2 conditions. They're stable. The circuit stays the same unless you do something. Now I'll take the circuit apart to make it a little easier to see what's going on. So as I said, this comes to the middle pin. And so we'll just remove that jumper wire. And now you can see the rest of the circuit a little bit better. So the LED and the anode of the pin, they come to one of the terminals of the switch. There's a gap between the 2 switch terminals. So this LED and this resistor are only connected to each other. The other end of the switch comes to here. So I'll remove the SCR. And now you can see better that this row comes to that terminal there, and then when I close the switch, that gives it an easy path to ground. So positive goes through the resistor, the LED, and then it would be going to the SCR, but if I close this switch, there's less resistance through the switch than the SCR, and so the current path will just go here, cutting off the SCR and turning it off.